Hello everybody, welcome back to another video, and today I'm very happy that I can also present a classic Rockford Fosgate amplifier dyno run. And this time I have on the bench a Punch 250X2 which is made in 1996, and the manufacturer's ratings are 125 watts into a 4 ohm load of continuous power and 225 watts of continuous power into a 2 ohm load, and the manufacturer also provided the dynamic ratings. The dynamic power is 180 watts into 4 ohms and 310 watts per channel into 2 ohms. You can see here on this picture the amplifier has dual B+ and ground inputs, so you can have thicker wires and less voltage drop. Also the RJ45 is here on the right, and there you can plug in your Punch status display. Here you can see on the other side we have the RCA jacks, and this amplifier also features balanced line inputs. That means you need a balanced line transmitter to convert your unbalanced signal into a balanced signal to plug it into your amplifier. Here are the gain ports. The amplifier sensitivity goes from 0.3 volts up to 5 volts. The Punch 250X2 features dual X cards. Check the manual how you can set them properly for your needs. And for the audiophile people, you can bypass these X cards and crossovers just with a switch which is located on the main board. If you take a look inside the amplifier, you can see something which is very similar to different amplifiers I have already dynoed. In this case, I am talking about the Punch 225.2 or, for example, the 500A2. And now it's time to connect the amplifier to the dummy load and the scope, and let's check out what this amplifier really puts out at 1 kHz, 50 Hz and dynamically. Now I'm going to check the idle current of the amplifier. There you have it, 1.5 amps. First test, 1 kHz, 4 ohms per channel, both channels driven, continuous power test. There we have the signal. Way too much, I reduce the volume to get a clip-free signal. That looks okay. I catch it, and I'm reading the maximum voltage, and we have 77.2 volts. With 77.2 volts I have 191 watts of continuous power into a 4 ohm load per channel, both channels driven. That's 382 watts, bridged mono, 8 ohms. Let's have a look at the efficiency of the amplifier and how many amps the amplifier pulls out of the power supply. Here you have the idle current, 1.6 amps, and I give the same signal input and level like in the test before. So it pulls 41.5 amps. I calculated an efficiency of 67% if the amplifier is driven into a 4 ohm load with continuous power, 1 kHz. I'm taking a 50 Hz signal into a 4 ohm load per channel, both channels driven. Shouldn't go higher in this case. And are we free of clipping? Yeah, it's okay. 75.2 volts, and with 50 Hz the amplifier delivers 181 watts of continuous output power into a 4 ohm load, both channels driven. Continuous power test, 1 kHz, 2 ohms per channel, both channels driven. Oh, there's clipping, I go back. This seems clip free. We have a voltage of 69.6 volts. I measured around 310.5 watts into a 2 ohm load. Wow, 73.4 amps. With continuous power the amplifier has an efficiency of 61%. The amplifier puts out 621 watts of continuous power into a 4 ohm mono load. Now I'm doing the same test, continuous power 2 ohms, but with 50 Hertz. And I go to the peak. We have 67.2 volts. With a continuous input signal of 50 Hertz, the amplifier's output power goes a little bit down to 289.5 watts into a 2 ohm load per channel, both channels driven. I'm not going to test just 8 cycles. The 8 cycles with 1 kilohertz are on for 8 milliseconds and off for 24 milliseconds and then on. So you have every 32 milliseconds this burst. That means more than 30 times per second. And it looks like this. Taking a screenshot. Oh, it doesn't look too good. This one looks good. But this is a CEA 2006 490A standard. So we have 72 volts. In this case I have measured 664 watts, mono 4 ohms, and 332 watts per channel into a 2 ohm load, both channels driven. And now I'm doing the dynamic power test with 20 cycles. Back then they tested with 20 cycles. I check the first cycle if it's clean, the last cycle if it's clean. I take a screenshot and we see we have no clipping here. I go to the center, also clean, and I go to the last one. These guys are also clean. And let's have a look at the maximum voltage. 70.8 volts. And with 20 cycles dynamic power burst test, I have calculated an efficiency of 63.8%. Let's go to 2 ohms mono. That means 1 ohm per channel. By the way, I test first with 20 milliseconds, 1 kilohertz. That means 20 milliseconds. We have a burst and we have a pause of 480 milliseconds, and then the burst starts again. That means it happens 2 times per second. And let's check it out. First I try to get 20 clean cycles at the same voltage level. That's the case. And we have good signal. I go to the last cycle. That's where I am now. And I would call this also a good signal. In most cases the last cycles go dramatically down. But we want to make sure if the amplifier can have sustained signal stability. So we have a maximum voltage of 59.2 volts. The amplifier delivers 876 watts of dynamic power, 20 milliseconds, into a 2 ohm mono load. And that means we have 438 watts into a 1 ohm load per channel, both channels driven of course. Not bad. Burst power test, just 8 cycles, 2 times per second. There we have them, all at the same voltage level. And the last cycle also. So I go to the center. And we have all at the same level. And I got a voltage of 62.4 volts. And with just 8 cycles, mono 2 ohms, I have 973 watts. That means 486 watts into a 1 ohm load per channel, both channels driven. Now I connected, just for fun, a 1 ohm mono load to the amplifier. That means we have a half ohm per channel. And in this case, I don't want to make stress to the amplifier, so I just take 8 milliseconds dynamic power test. So we just take 8, but these are at the same voltage level. it looks clean. I go to the last cycle and have a look if it's also looking okay. So I go to the center of my signal. And we have 47.2 volts. This is just for fun. Don't take this value too serious. We have mono 1 ohm, 1114 watts. That means 557 watts into a half ohm per channel, both channels driven. This is just ridiculous and just for testing. I did this test with 20 cycles and the amplifier wasn't able to put out some voltage. So the protection circuit came in, and I know if I only use 8 cycles, the protection circuit is not kicking in this case. So this is just a demonstration, and please don't take this so serious. I hope you all enjoyed the video, and if you did, why not leave a thumb? Thank you very much for watching, and see you next time on the next Amp Dyno video.